Every astronaut who returns from the International Space Station comes back slightly younger than they would have been on Earth. It's not science fiction, it's measured fact. Atomic clocks have measured microsecond-scale differences on long-duration ISS missions, with astronauts experiencing approximately 0.01 seconds of time dilation during a typical 6-month stay. The difference is microscopic, but it's real and measurable with atomic precision. This isn't just a curiosity, it's proof that time itself is not what we think it is. Einstein predicted this over a century ago with nothing but pure thought, and today's technology has turned his wildest theories into everyday reality. But how did one man's simple observation change everything we thought we knew about time? The patent clerk's revolutionary moment. In 1905, Albert Einstein worked as a patent clerk in Bern, Switzerland, spending his days reviewing applications for electrical devices and mechanical contraptions. But his mind was elsewhere, grappling with physics questions that had tormented him for years. Einstein used his daily tram commutes to escape into the abstract realm of theoretical physics, and it was during one of these routine journeys that he conceived a thought experiment that would revolutionize modern physics forever. The Ziklag clock tower dominated Bern's skyline, its massive hands marking the steady passage of time for the entire city. Einstein had passed this medieval timepiece thousands of times, but as his tram pulled away from the station that evening, something different stirred in his thoughts. He watched the clock tower grow smaller in the distance as the tram gained speed, and the physics problem that had been eating at him for months suddenly crystallized into a single piercing question. What would happen if this tram could somehow accelerate to the speed of light itself? Einstein closed his eyes and let his imagination run wild. In his mind, the tram accelerated faster and faster, reaching velocities no machine had ever achieved. At 299,792 kilometers per second, something extraordinary happened to his view of the clock tower. He realized that at light speed, a distant clock would appear stopped, even as it continued ticking at the tower, showing time must slow with motion. Yet Einstein knew with absolute certainty that back at the tower, citizens of Bern continued to observe the clock hands moving at their regular intervals, marking seconds and minutes as they always had. This visualization struck Einstein like a thunderbolt. The implications crashed over him in waves. Time was not the universal constant that Newton had assumed. Time could slow down, speed up, or even freeze depending on how fast you moved through space. The faster you traveled, the slower time became relative to everything you left behind. Motion through space directly controlled motion through time. Einstein opened his eyes and stared out at the real clock tower, now just a distant speck in the evening light. His mind raced through the logical consequences of this thought experiment. If motion through space affected the passage of time, then time itself must be flexible, malleable, subject to the same physical laws that govern everything else in the universe. This meant that two observers moving at different speeds would experience time at different rates, even though both would perceive their own clocks as running normally. The patent clerk who spent his days analyzing mechanical inventions had just stumbled upon the most revolutionary concept in the history of physics. The two dimensions that humans had always considered completely separate were actually connected in the most fundamental way possible. Increase your speed through space, and you decrease your speed through time. The relationship was not just theoretical. It was mathematical, precise, and absolute. Einstein gripped the tram's handrail as the full weight of his discovery settled in. If time could slow down under certain conditions, what other assumptions about reality were completely wrong? Perhaps space itself was not the rigid, unchanging stage that Newton described. Perhaps the very fabric of the universe was far more dynamic and interconnected than anyone had imagined. The questions multiplied faster than he could process them, each one opening new doors to mysteries that would reshape human understanding of existence itself. This simple thought experiment aboard a Bern tram would eventually become the foundation for technologies that define modern life. Today's GPS satellites must account for Einstein's time dilation predictions every single day to maintain their accuracy. Without corrections based on his 1905 insight, navigation systems drift by miles within hours, making precise location impossible. The same theories guide particle accelerators that probe the deeper secrets of matter, enable atomic clocks that synchronize global communications, and explain phenomena observed in the most distant reaches of space. Einstein's mental journey from frozen clock hands to flexible time revealed a hidden conflict at the heart of physics. As the tram continued its route through Bern's narrow streets, Einstein's thoughts had already leaped beyond the boundaries of his century. He sensed that his discovery would require abandoning humanity's most basic assumptions about the nature of reality, but he could not yet see the full scope of the battle that lay ahead. The patent clerk stepped off the tram and walked toward his apartment, but his mind remained fixed on the implications of his revelation. That frozen clock tower had shown him something profound about the structure of the universe. Space and time were not separate, independent dimensions, but part of a unified fabric that could bend, stretch, and warp. Einstein knew he had uncovered something that would challenge every physicist's understanding of reality, but the path forward would demand confronting a fundamental contradiction that had been hiding in plain sight for decades.